Hello everybody, and welcome back to another video. In this video, I will be covering force. Now, force is defined as the mass of an object times the acceleration of an object. So, if you have 9 kilograms accelerating at 2 meters per second, then you have a force of 9 times 2, 18 kilograms, this is supposed to be squared, meters per second squared, which is equal to 18 newtons is the unit of force. Now, the force caused by gravity, denoted as Fg, is equal to mass times the gravitational acceleration strength, so mg. So if you weigh, also for the sake of this video, although g is equal to 9.81 meters per second squared, we are just going to be using g is equal to 9.8 meters per second squared. It will not change our calculations at all, so just get rid of this idea. So we have a mass of 10 kilograms, then our force of gravity is equal to 10 kilograms times 9.8 meters per second. And we have that our force of gravity is equal to 98 newtons. Now, a tool used for solving a force question is a free body diagram, where you will label a point, which is your system. So let's say a ball is accelerating. This would be your ball. And then you label all the forces and their direction. So let's say you have a force Fg pulling the ball downwards. This would be denoted as Fg, and the ball is on a flat table. So this table must be exerting a force in the opposite direction to counteract the gravity force, so that way the net acceleration in the y direction is not just Fg. So this force, Fn, cancels out with Fg, so that way the floor isn't caving in. And then let's say the kicker kicked this ball directly forward, and we will call that Fa for force applied. So now let's look at a problem using this. So we have a person whose mass is 90 kilograms in an elevator which is accelerating upwards at 2 meters per second squared. What is the value of the force exerted on him by the floor of the elevator? Now, we know that force of gravity is equal to mg, and that net force is equal to mass times acceleration. So let's draw the free body diagram. Now, first off, we're going to label to the side on a little arrow that we're accelerating upwards at 2 meters per second squared. Now, we are going to draw our free body diagram right here, where we have our force exerted by the floor of the elevator, as this person is just sitting on the floor. So the force must be pushing him upwards so his gravity doesn't cause it to cave in. And there's a force of gravity downwards. So this is our free body diagram. I'll draw this in blue. Now, our net force, F net, is equal to the sum of the forces. So in this case, since Fn is going upwards and Fg is going downwards, we can label Fg as being negative since the acceleration is upwards. So the sum of our forces is going to be Fn minus Fg. And this is equal to our net force, which we also know is equal to ma. Now, bringing this equation over here, we have Fn minus Fg equals ma. And we know that Fg is just mg. And we know that m is just 90 kilograms and g is just 9.8 meters per second. So we're going to write 90 kilograms times 9.8 meters per second squared. And then we have our natural force subtracting that is equal to our mass, which is 90 kilograms, times our acceleration, which is 2 meters per second upwards. So times 2 meters per second squared. I keep on saying meters per second, I mean meters per second squared. So since we are trying to solve for Fn, we are going to add this term to both sides, and we get Fn is equal to 90 kilograms times 2 meters per second squared plus 90 kilograms times 9.8 meters per second squared. Now, plugging this into our calculator, we get that our force exerted by the floor of the elevator is equal to 1,062 newtons. And that is our answer. I hope you enjoyed this video. Please like and subscribe for more. And yeah, thank you for watching.